Welcome to today's session. It should be just under an hour, and what we'll discuss is just what you need to be thinking about when you've got sites, what you need to be thinking about in terms of refurbishment, health initiatives, control of dust. But I'll pass you on to my colleague Martin, who will go through the agenda and deliver the first part of the session. So welcome.
Okay, good afternoon now, officially. So the agenda for the session, we're going to go through a bit on temporary works. What does it mean? What is temporary works generally? And what are your responsibilities when it comes to temporary works? We'll have a look at health implications of refurbishment projects, some things that the HSE are going to significantly focus on as per their business plan, which has been issued for 21-22. David then will touch on fire and also existing services within a building as well, what to be aware of. So as you can see, before we actually start, where this has all come from is at the bottom corner here, we've got this HSE business plan. So our construction sector plan outlines what we'll focus on. It's got SMEs carrying out refurbishments. So clear as day, they are focusing on small and medium enterprises carrying out refurbishment projects. They're also looking at embedding the requirements of the CDM regulations, construction design management regulations, through targeted inspections of duty holders. So again, they don't specify which duty holders, so it could be any element, client down to contractor. Prevention and control of occupational lung disease, especially asbestos and dust generally. COVID control measures will also be included in all interventions as well, so they will focus on that. And as it's got there, one of their main deliverables of the 21-22 business plan is respiratory risk health focus initiative of inspections, covering all sites, varied sizes, activities, and hopefully going through the health implications section today, you may pick up a few things. So that's the agenda. Oh. So what are temporary works? So basically temporary works, widely used expression throughout the construction industry, but it's for an engineered solution used to support, protect an existing structure, support or protect the permanent works during construction, support an item of plant or equipment, the vertical sides or side slopes of excavation, or provide access. Ultimately, anything that will require a permanent work structure will need some form of temporary works. Now, this is very varied when it comes to temporary works, which the next slide will show you. It's categorized from a British standard, from low risk, if you like, from the very basic, looking at a manufacturer's instruction, all the way to Cat 3 temporary works, which is external verification. But hopefully, by clicking onto the next slide, you'll understand the basics, which is what we'll look at. So examples of temporary works, as you can see here, there's a lot of information we've got on this slide, but ultimately we've tried to break it down into categories. So you have an example to take away with you. So going from category 0 all the way up to 2 and 3, and I'll explain how that works. So category 0 is simple or potentially low risk temporary works. It's got that word there, that keyword, potentially low risk, because it can differentiate depending on what you're actually doing. So interestingly, things like a simple standard scaffold, mobile scaffold towers, which has been erected in line with the PASMA guidance, Harris fencing, as long as it's in line with the Harris detail. We'll call it an off-the-shelf solution. Okay, so that's a category 0, potentially low risk temporary works. Category 1, more or slightly more complex or potentially medium risk temporary works. As you can see there, false work, form work, needling, propping structures, temporary roofs. And what a category 1 is it has to be designed. Okay, it has to be designed by an engineer and passed to a colleague for verification. Now, this process of being passed to a colleague, it can be discussional based. The person who's designed it can sit down with the colleague and say, look, this is what I've designed and this is the conclusion I've come up with and these are my calculations. Do you agree? Yes or no? If it's a tick in the box, they agree, they can move on to site. Now, the complex or potentially high-risk temporary works, as you'd imagine, it steps up when it comes to the actual verification elements. So often when we are on site, when a temporary work such as a crane base comes to site, we don't really understand how it's got to that level, how it's been designed, how it's been thought of to the process of it actually being implemented on site. So how that works is ultimately for a category 2. Category 2 is designed by A individual. It then gets passed to B individual from the same place of work, but this time they don't get the calculations. The calculations are then thought of by the B person, whoever this may be. As long as the calculations marry up, it can then be approved for site. So that's the next step up, category 2. Category 3 is an external verification. So basically, somebody designs said temporary works. It then gets passed to an alternative company with no communication at all. There's some drawings which I've designed. Can you please verify them? Make sure that the calculations are correct. We'll then review it. If they both marry up, brilliant stuff. They can crack on and go to site and be developed. And as you can see there, a little note at the bottom, categories 0 to 3 are stipulating BS 5975, which is the temporary works British standard. And this is where this all comes from, the level of check. Slide. So procedures for temporary works. Contractors should be able to demonstrate that they have in place effective arrangements for controlling risks arising from temporary works. These are usually captured in a temporary works procedure, which will contain most of all of the following elements. Now, as I mentioned there, temporary works can be very basic things like a standard scaffold, mobile scaffold tower. So if you do any of this, you will need a temporary works policy and procedure. It may be worth reviewing it just to make sure it meets these relevant criteria. So the first thing there, appointment of a temporary works coordinator. Now, some of you may have temporary works coordinators training, absolutely perfect. And you'll know that a temporary works coordinator's job is not to do temporary works, not to design temporary works. You are just a trigger. You're a trigger to say, yes, that needs a design, or I'm not too sure on that. I think that could do with a design. You're not actually carrying out the work. You're a trigger to ensure temporary works are carried out properly, suitable and sufficient. Preparation of an adequate design brief. So a design brief is you specifying what you actually want on site, whether it be a cofferdam, a caisson, anything that you want on site needs to be in a brief. Completion and maintenance of temporary works register. Now, a temporary works register is a document which will be reviewed by the HSE if they come and have a look at your site. And again, a temporary works register is a log of all the temporary works you have. And this could be as simple as Harris fencing, the welfare provisions on your project, all the way up to design scaffold. And that will set specific criteria, such as the category that you've put it in, category 0, 1, 2, or 3. Who's designed the drawings, who's undertaken the inspections, but we'll show you a template one on the next slide. Independent checking of temporary works design. Again, that's category 2 or 3. Issue a design check certificate if appropriate. So a design check certificate actually is something which is being pushed a lot more. And what that is if you do a 2 or 3 category temporary work, what principal contractors or contractors generally are requesting now is this design check certificate. And ultimately what that is a stamp of approval to say this has been checked in line with whatever standard and who has checked it, and it'll be signed off accordingly. Yeah, and that's one of the main criteria in a temporary works design. Pre-erection inspection of temporary works materials and components. Again, this is something which isn't really pushed, but ultimately it's done by the specialist contractor. So for a scaffold in particular, doing a design scaffold, they should be doing a pre-erection inspection of all the temporary works materials and components. So pre-use check, basically. Next slide, please. So just briefly touching on a temporary works register. I'm conscious that we are strapped for time when we're only talking an hour when it comes to temporary works and all the other things we're going to cover today. But this here, I thought I'd pop in just to give you an idea of what one should look like. So as you can see on the left-hand side there, description of activity, we've got some different examples. Don't get me wrong, that's not set in stone. What we've put on there, Cat 1, Cat 2, it could be whatever you deem is necessary. Some people might just knee-jerk reaction when they come to a high-risk activity, just banging in a Cat 3 just because they want that additional check. can see design prepared by whoever, risk assessment prepared by whoever, and it goes on. But interestingly, one of the main features of this is that drawing number. So making sure that we have actually erected it in line with a specific drawing that has been checked accordingly. So yeah, if you don't have one of them, again, just contact us after this if you wish, and we'll send the template over. So that's a little bit on temporary works. We're now going to move on to the health implications, which, as you can imagine here, is quite significant when it comes to refurbishment activities. So we'll have a look at respiratory overview generally. We'll dig into a little bit asbestos, but again, I'm not going to dwell on that too much because I'm assuming that most people know about asbestos. We'll look at silica, a bit manual handling, noise, vibration, then just kind of finish off on any other respiratory risks which are applicable. So the respiratory overview. Now, as you can see here, the numbers are quite high to start with. Now, why I wanted to put this one on was because it kind of shows the significance for the HSE's kind of shift between health and safety. As you can see in that bottom left-hand corner there, we've got 111 fatalities in 1920, which is obviously the last figures we've got available currently. But look at that based against just lung diseases alone, so health impacts. 111 safety fatalities, let's call it, and 12,000 health just on lung diseases alone. So you can see why the health and safety executive shift is now changing to health implications. And I'm sure you're aware that we are very good when it comes to safety. We know if we put our hand inside a chop saw and put the chop saw down, the potential is we're going to chop our arm off. But trying to change the safety culture on a construction site for somebody who's drilling into a wall without a dust mask on, and then trying to tell them in 40 years' time they may bear significance against that drilling activity is very difficult. So it's a challenge across construction generally. But again, something we're very passionate about pushing. So as you can see there, it's split down into different categories. Mesothelioma, which is a direct link to asbestos-related disease, asbestos-related lung cancers generally, COPD, chronic obstructive pulmonary disease, and then other sort of allergic alveolitis as well, which accounts for around about 12,000 deaths per year. Very significant. So we'll dive into it in a bit of detail now. Asbestos. So asbestos, everybody knows it's in any building built prior to 2000. It stopped being used in 1999, and which is quite recent, if I'm being honest with you. It's not too long ago, 1999. But what we've got in here is some examples where prohibition notices may be issued. And this isn't just plucked out of the sky, by the way. This is actually taken from the HSE's website. So what they're identifying is for a prohibition notice to be issued, or may be issued, there's no R&D survey on site, no refurbishment and demolition survey. What they have noticed in the past is that people are operating off management surveys, which I'm sure you'll agree is just not suitable or sufficient for the activities of a refurbishment project. Our R&D surveys are intrusive surveys. They're going to get below the surface and understand what the building fabric's made of, where a management survey is literally just what's on the surface. Insufficient R&D surveys. So you might have an R&D survey on site, but it might not be significant to your work activity. If that is the case, you are more than within your rights to request a localized survey, specific to the task you're carrying out. No action taken to meet recommendations of an R&D survey. Working practices disturbing or likely to disturb asbestos-containing materials. And finally, significant fibre release and spread from asbestos-containing materials is where they will put a prohibition notice in place. Examples of where improvement notices may be issued: no insufficient information, instruction, training. No asbestos awareness training, for example. Asbestos awareness training won't allow you to work with asbestos. It's purely an awareness training. So you can identify it and put actions in place. Non-licensable work with asbestos, including notifiable non-licensed work, and licensable work with asbestos. So duty of employer in relation to information, instruction, training is, it must be in place. Simple as that. So how do we comply? A refurbishment R&D survey carried out on the building covering all of the work areas, not just some. It has to be comprehensive, has to cover all your working areas. Holistic approach. Licensed asbestos removal being carried out by licensed contractors with enclosures, decontamination units being utilised. It'd be very rare that doesn't happen, but there has been cases in the past where asbestos has been removed in an unlicensed manner, let's say. The asbestos report covered with all operatives during the induction process. Now that's critical. If you've got any asbestos on your construction site, you must inform operatives. Even if they're not directly exposed to it or going to be working in that specific area, they need to be aware of where it may lie. ACMs being clearly identified on site as well, whether it be a sticker or some sort of visual indicator. And asbestos awareness training for all operatives on site. Like I mentioned, any building built prior to 2000, all operatives must have asbestos awareness training. So silica. Silica is, the awareness is on the rise, I'd assume, because of the health implications associated with it, silicosis being the main one. Again, it's a chronic disease, silicosis, and unfortunately, trying to shift people's opinion or culture or awareness is quite difficult because of the latency period, shall we say, which could take up to 40 years to develop something like silicosis. But some examples here of where prohibition notices may be issued. So we've got inadequate controls in place when cutting concrete curbs, flags, blocks, or roofing tiles with a cut-off saw. Ultimately, anything that's got silica in it, silica sand, it's an issue. Chasing concrete and rake and mortar, high energy scaffolding, grinding tools, or longer duration breaking out work in enclosed poorly ventilated areas. Dry abrasive blast cleaning. So anywhere, as you can see, which is creating airborne debris, is where you want concerns. Examples of where improvement notices may be issued is no or insufficient information, instruction, training, again, being issued. So as basic as it may sound, you providing your employees with on-tool extraction sometimes just isn't enough. And what I'm saying here is you need to be giving them some information, instruction, and training on the use of these bits of equipment. Because some people have them on site, but they just don't understand why they need to be there. Next slide, please. So I'm hoping this is going to work now. We've got two, you might want to turn your volume down on your speakers as well. I don't want to wake you up. So we've got two videos here. One's uncontrolled and one's controlled. And what it is somebody using a cut-off saw on a curb. For RCS, control measures must be effective in keeping exposure below the workplace exposure limit, sorry. And as you can see, what's interesting when it comes to uncontrolled is how high the levels actually are. And what they're doing is they're monitoring in their breathing zone. And now your breathing zone is what they classify about 30 centimeters around your mouth and nose. So we'll watch the uncontrolled video and then we'll put the controlled one on. I'll put the control on. That's just to give you a brief idea of the difference. I mean, it's a very basic video, but often shows you more than me talking, to be perfectly honest with you. The difference between uncontrolled and controlled. Now, simply just using water suppressant on something like that isn't enough. We should also be expecting our employees, through training and awareness, to be using dust mask as well as a secondary measure. Because it won't capture everything, as you see in there. Even on the control version, it did peak a little bit above the workplace exposure limit, but it's averaged over an 8-hour period. I appreciate that, but it's just to let you know that it doesn't capture everything. Does water suppressant. Next slide. So examples of how we can comply when it comes to silica dust generally. So cutting concrete curbs, flags, blocks, roofing tiles, we need to be using suitable water suppression. Something that's effective, something that works, and it's maintained and inspected accordingly. Often you'll see a bottle on site, but actually it'll have no connection to the actual cut-off saw itself. But when it comes to electrical use equipment, as you can see there, so chasing concrete or drilling into walls, we need to be using on-tool extraction. And these can come in all shapes and sizes, varied forms. Hilti have done a lot of research, and there is others on the market, obviously, but Hilti seem to be leading the way when it comes to on-tool extraction, that's for sure. So a few examples on other respiratory risks. Believe it or not, that mask in the bottom left-hand corner there was actually taken by, was there somebody doing an inspection? Somebody doing an inspection, and that was the mask that the operative was actually using. And obviously, as you can see there, this individual clearly didn't have the relevant instruction, information, training to be operating with a mask like that. But the failure by the employer is to ensure that exposure of his employees to substances that are hazardous to health is either prevented, or whether this is not reasonably practicable, adequately controlled. So as you can see here, on-tool extraction is a great idea. However, we must ensure that we're wearing secondary measures as well, because as we mentioned, even with a woodworking saw like that, you can see the dust which is still scattered about. It's not going to capture everything, so a dust mask must be worn. Now, when we're wearing dust masks, face fit testing is still a critical element, making sure that the operative's face is acceptable with the mask he's using or she's using. But we'll get on to face fit testing soon. So vacuum extraction, you'll see it all. You'll see all sorts when you go to a construction site. People using Henry Hoovers and Dysons and cordless Hoovers, which just aren't acceptable when it comes to the HSE's opinion of what we should be using. We should be using class M or H filters, HEPA filters, high efficiency particle filters, making sure that they actually are working. They are extracting as much as they need to be extracting. Again, they're available to hire from hire companies at a reasonable sort of charge. But again, in the HSE's opinion, we should be using these at all times. There's no real excuse for not using. So with a true or false, if all operatives are wearing a dust mask, there is no need to use water suppression on a still saw. I'm sure you can guess the answer to this one, but it's false. The dust mask must be worn along with water suppression. I've already touched on that earlier today. So whenever we're using a still saw, anything to cut concrete, drill, the first consideration is, can we take it away from source? And then we consider a dust mask. We can't just walk up to every activity and think, yeah, as long as we're wearing the right PPE, we'll be fine, because it just doesn't work that way. It's your last line of consideration. If operatives are wearing respiratory protection, they must be clean shaven, true or false? The answer is false. There are certain air-fed hoods that rely on positive air pressure to prevent any particles entering the hood. So again, a lot of people jump on the bandwagon about, oh, well, I've got facial hair, the mask will never work. I can't do my job anymore. It's not always the case. Yes, I appreciate these air-fed hoods come with a lot of cost involved. However, there is alternatives. That's what we're trying to get at here.
If you are wearing a tight-fitting respiratory protector, the operatives should be face fit tested and they should be clean shaven at all times when wearing the mask. Absolutely.
Once an operative is being face fit tested for an FFP3 mask, they can wear any FFP3 mask. Often we get this question asked to us. The answer is false. They'll be tested on a certain make and model of a mask, so an FFP3, alpha Solway, whatever it may be. Once they've been tested on said mask, that is the mask for them. They can't then use an alternative like a 3M FFP3 because we're unaware if it works or not because I haven't had face fit testing. If asbestos is in good condition, is it okay to leave it in place? The answer's true, absolutely. To be honest with you, as you quite rightly know, asbestos is probably the best thing ever in terms of a construction material we ever come across. The only issue is it killed pretty much everyone it come into contact with, which is a big negative. However, if you've got asbestos in good order, it's maintained accordingly, it's been sealed by a contractor, it's in good order, it'll probably last longer than any building. So yes. Okay, coming up with enough for me before David takes over. We're touching here on a bit on manual handling. So manual handling, the awareness of manual handling is around. People know what manual handling is. However, fulfilling its requirements often is a bit of a stumbling block. So examples here of when improvement notices may be issued on companies. So it's got no or insufficient information, instruction or training delivered. So as you can imagine, that's an improvement notice. What about prohibition notices, do you think? Consider things like risk assessment. Manual handling risk assessments must be in place. I'm going to say it for every activity, but you know yourself, risk assessment should be based on the significant issues. So examples of some good manual handling practices include manual handling training. It's hard to argue you shouldn't have manual handling training on a construction site based on the fact that construction's heavy labour. Manual handling risk assessments there. Manual handling risk assessment is slightly different when it comes to a standard risk assessment because we follow things like the tile factors, task, individual, load and environment, making it specific to the individual. Suitable supervision for the task is needed 100%, and suitable manual handling aids can be used as well, depending on the nature of the activity, the site constraints, whatever it may be, and also the area you're actually working on in terms of the condition. So some good practices, you can see some pictures here which we've used. That's one on the right hand side there is actually a motorized manual handling aid. It operates at very slow speeds, but ultimately what it does is it just takes that extra burden off the push or pull activity. So you've taken the load off the individual and also you're reducing that push or pull. So it's a really good bit of kit. We've come across it recently. Obviously you get different lifting aids like that materials hoist there for vertical distribution of your loads. Again, preventing people from walking up and down stairs, and the list just goes on and on. But as you can see here, some really good elements of manual handling activities. Okay, vibration. Examples of where prohibition notices may be issued. What it's got is clear evidence that exposure is above 5 meters a second and there is demonstrable risk, i.e. not a one-off exposure. So what it's getting at is basically constant abuse of vibratory equipment over long periods of time. Prohibition notices may be issued if there's evidence. Examples of where improvement notices may be issued. It's got no or insufficient risk assessment and controls. No or insufficient information, instruction, training. So when people are questioned on the vibration levels or how long should you be using that equipment for, and your operatives are just none the wiser, that's often a bit of a red flag there. So how do we go about measuring vibration? Vibration can be monitored and measured in varied ways, but we need a starting block. Now, every piece of equipment which vibrates will produce something called a vibration magnitude. The vibration magnitude is applicable to cordless drills, all the way up to whacker plates. Everything's got varied levels. If you are not fully au fait with what your operatives are exposed to, you need to identify what equipment they use and access their manufacturer's instructions. It will tell you everything you need in terms of vibration levels. Once you've got that information, you can then dissect it, as you can see here where that red arrow is pointing to, and put it onto this monitoring information here. On the left hand side, you've got something called the halves ready reckoner. Now, this is a visual indicator, and you can base it on the left-hand side, the vibration magnitude, where it's got circled 5 here in this instance. And then along the bottom row, you've got it identifying 3 hours, just as an example. Now, we've got action levels and limit values here. And as you can see, on the left-hand side, Hav's Ready Reckoner, as soon as you hit 100 points, you're above the exposure action value. So you need to start doing things like considering rest breaks, considering job rotation. You need to limit or reduce your employees' exposure, is what I'm saying. When you come to the red area, you're above the exposure limit value. Now, your exposure limit value is actually 400 points. So once you're at 400 points, that's it when it comes to vibratory tools over an 8-hour period. However, it's also based on your weekly average as well. So you need to consider that. On the right-hand side, you've got something which makes life a lot more easier for you. It's the exposure calculator, and it's freely available from the HSE's website. Fantastic piece of equipment, because all you need to do is, where it says hammer drill and then vibration magnitude 15, that's all you have to do. Literally put them details in. It will pop up with the exposure points per hour for you, how long you're going to take before you reach the action level, and then the limit value. There's another box there which says exposure duration. You put how long your operatives actually use that piece of equipment for, and it will give you an exposure point value. So in this instance here, we've got a hammer drill with a vibration magnitude of 15. We can work with it till we reach our action level for 13 minutes or limit value for 53 minutes. But actually, we've used it for 12 minutes, which has given us a point score of 90. So it's absolutely fine. And it's got a green box there saying we're absolutely within what action value limit. Similarly, when it comes to noise and vibration kind of go hand in hand. Vibration's got its own limits, noise has got its own limits based on decibels, frankly. When it comes to decibels, you've got 80, 85, 87 decibels. 80 decibels being general rule of thumb, you're 2 meters away from somebody and having to raise your voice. That's when you've got some sort of issues going on. Risk assess it. If people request hearing protection, give them it free of charge. 85 decibels, mandatory hearing protection. 87 decibels over an 8-hour period is legal limit. You shouldn't be exposed to that. So examples being certain high-risk tasks where the noise is above the 85 decibels and when nothing's in place. Or where improvement notices may be issued, again, no insufficient risk assessment and controls. And often where it falls down, in my opinion, is this employee sort of engagement process. So no or insufficient information, instruction, training. I really believe in this engagement with your operatives and letting them know how it can affect them long term. Again, very similar to noise, vibration. When you go on your manufacturer's instructions, it will actually give you the key criteria. So it'll tell you exactly what sort of how sound pressure and sound power levels they'll be pumping out for each individual piece of equipment, which will allow you to risk assess your equipment properly and also make a judgment call based on the PPE as well, actually. Next slide. So again, how to manage noise in the workplace, assess your risks. You know, as best as your risk assessment is going to be is how good you assess your risks, how quick you identify your hazards, that holistic approach. And what we've got to bear in mind is with vibration and noise, the fact that all these measurements are taken in pretty much laboratory sort of environments. You know, they haven't been booted around a construction site for 6 months and they're not full of dust and debris. So of course the vibration and noise levels are going to be a lot lower than what they may be 6, 8, 12 months time on a construction site. Provide hearing protection while also considering what other measures you can take, i.e. get the equipment which is producing the least amount of noise. Don't just automatically dive on hearing protection. Make sure your legal limits of noise are not exceeded. Again, provide information, instruction, and training on everything we give operatives, whether it be hearing protection, a toolbox talk would be sufficient. How you maintain that equipment. Carry out health surveillance for operatives who are at increased risk of hearing damage, i.e. people who are exposed to noise for long periods of time, day in, day out. Keep up with good practice for noise control within the industry and consider noise in selecting tools and machinery, as we've just touched on there as well. A little bit on welfare. Welfare, believe it or not, is still seems to be an issue in construction industry, just based on the fact that refurbishment projects sometimes use existing welfare provisions. This one that the arrow's pointing to is just being out on the SHP website very recently from a prosecution. And as you can see, the company were issued a £200,000 fine in order to pay a cost of £7,000, if you like, for failing to comply with Section 2.1 of the Health and Safety at Work Act. And that was on the 16th of September 2021. So again, construction companies are still using stuff like that. Absolutely unacceptable. What we should be giving our operatives are things like this. And what we say is, when it comes to welfare requirements, is focusing on that sanitary conveniences. You know, like that picture I showed you before, yes, it was a toilet, but you can't say that was sanitary clean. No chance. Washing facilities, somewhere where they've got soaps, cleanliness provision, drinking water should be provided, whether it be bottle format or even bringing in a cooling container. It should be issued to employees free of charge. Changing rooms and lockers for operatives who are expected to work outside or in dirty areas where they need to get changed to go home, and facilities for rest as well. And what we mean by facilities for rest are tables and chairs. Gone are the days where we should have benches on site, because the whole purpose of facilities for rest is so operatives can relax and actually rest against the back rather than sit and perch on a bench. So that's my little bit done, and I appreciate it's been a bit quick fire, but there's a lot of information we need to get through. So any questions at the end, we'll catch up with, but I'll just pass over to David there now.
Yeah, so part of my section is I'm going to be looking at fire on construction, especially within refurbishment projects. So just a brief one, I know everybody knows, but just to kind of quickly go through the fire triangle. To have a fire, you need heat, fuel, oxygen. So source of heat might be an ignition source, so naked flames, smoking, electrical equipment. All of those can potentially provide an ignition source. If you do have an ignition source, what's on your site that's going to provide fuel? Cardboard packaging, quite easily. There's a lot of stuff gets delivered. Pallets, timbers, all are going to help provide fuel. But again, flammable gases, flammable liquids. I've seen plenty of times over the years on site, piles of pallets, and that's also where they keep the petrol for the generator or for the still saw. You've got fuel, all it takes is an ignition source. And remember, your ignition source can quite easily be an arsonist at night. So again, is your site secure? Are you preventing people getting onto your site? And again, you often see it, piles of pallets right next to the house fencing. Beginning of November, just before bonfire night. Occasionally it's just that people are sometimes asking for trouble. Final section is oxygen. Generally you can't remove it, because if you do remove it, you're going to have other problems. However, you could have oxygen stores, pipe systems, chemicals in some refurbishment projects. However, it is fairly rare. So what can we do to reduce the heat and the fuel sources on site? So typical sources of the heat are ignition risks and how to control them. So switch off power sources at night. You're not having a rat's nest of cables, as you can see on that photo. Making sure you're providing, maintaining and appropriately using electrical equipment. Pat testing, because again, plenty of times on site. It is getting better now because most of the contractors, as technology advances, are on the battery tools. But if, for example, you had a plasterer, he's starting his mix at 9 o'clock and he's got a 110 cable, someone cuts through it, what's he going to do with that cable? Potentially join it back up together on site, because again, if he doesn't get that joined up, he's potentially losing a day's work. So again, it's management on site. Are you controlling it? Are the cables out the way? Can we use battery in the first instance? Avoiding naked flames, so things like oxyacetylene, welding on site. Again, sometimes it needs to happen. However, If it is happening, what we're doing to control it. But in the first instance, you should be thinking, can we actually avoid it? Can we avoid welding on site? Sometimes you can, sometimes you can't. Provide a smoking location. Now that seems sometimes a bit counterproductive. You say, oh, well, so you want to allow smoking on your site. What I'd say is, by providing a location, concrete or a tarmac base, suitable bins for cigarettes, what you're doing is you're controlling it, because unfortunately it's going to happen whether you like it or not. And I've been on sites where previously, I mean, I don't smoke, never have done. I've seen it where, oh, if you wanted a cigarette, it was a good 2-mile walk. What do you think happened on site? People were sneaking cigarettes, people were hiding them. The manager comes along, oh, to just quickly put it out and it's pushed somewhere. It could quite easily get pushed down a cavity. However, if there is a suitable facility in a suitable location, out the way of everything, it should hopefully get used by people on site. Preventing unauthorized access. We talked about it before, but reducing your risk for arson attacks. If somebody can get on site, someone can walk onto site casually, there's no control, there's no Harris fencing, and there's a load of pallets and some petrol kicking about, you can quite easily have an arson attack. If you can't prevent some things, what can you do to control them? If you can't that, making sure you're removing fuels, reducing your ignition sources. But again, you will have some heat. Also, how do you control that? Things like permanent work, hot works permits, control under permanent work, and have that hour at the end of the day where you stop the hot works and you're checking the area before the end of shift. So typical fuel sources. Rubbish, waste materials. The amount of cardboard used in some packaging is obscene sometimes. So you're getting a delivery to site, all those packaging materials, they've got to go somewhere. And often they might get stacked somewhere in the corner of site, or we're having difficulty getting a skip. All of a sudden there's a big pile of cardboard. And again, it's any spark, any ignition source, it's going to go up quite easily. Things like paints and thinners, again, we've got a lot of water-based stuff, which is a lot better, but you still have thinners. Some chemicals can still be flammable, glues. Making sure you're keeping minimum quantities on site. You're not having 30 tins stored that might last 2 years. It's sensible bringing stuff to site, keeping things in containers, keeping it out of the way, and making sure you're not stacking it up. But also, timber frame buildings, the components of the structure can be flammable. So with that, you've got to start thinking of building your compartmentation as you go. Because again, timber frame, it is getting a lot more popular. There is a good guidance for timber frame buildings online. But also wood shavings, wood dusts and fuels for machinery. We'll go back to the respiratory that Martin touched on earlier. If you keep keeping them dusts down, you've got vacuum extraction. Yes, you've got the COSH element of making sure people aren't breathing in hazardous substances. But if you keep them wood dust down, the wood shavings down, you also help them with the fire as well. So it's not just one thing by having vacuum extraction, it can also help with fire as well. But remember, it's an electrical item, so you need to have it serviced, it needs to be tested, etc. So various issues. So maintain the structural design precautions. Again, I got involved with a construction phase plan. It was replacing the fire doors in sheltered accommodation. About 20 doors to change, and it's a case of being really clear with the site manager, with the joiner. You're taking off one at a time. The joiner isn't coming along taking all 20 doors and replacing them one by one after that. No, he's got to take one off, put the new one on, one at a time. It's not a case of just decimating all the structural compartmentation of the building by taking all 20 off and then starting one by one, putting them on. No ifs, no buts, that could not happen. And also reiterating the joiner, look, if you go to put that new door on and it doesn't fit, doesn't work, it's not right, that old one goes back on at the end of the day. But for overnight, no ifs, no buts, it's not just left out. and it was being critically clear with them at the very start of the project that this is how it had to be done. Maintaining compartmentation, or we're installing it as we go. So as you start getting higher in the building, you're putting your compartmentations on, you're putting your fire doors. Now I understand that sometimes fire doors can be, the final product is very expensive. However, possibly looking at sacrificial fire doors that are just a cheap standard FD30 or an FD60 door, and it's installed and it's going to be taken down before the end and the proper finished products can be put on. But again, by putting that door on, you're maintaining the fire compartmentation as you go. If you are doing refurbishment work, you might have to take structural walls, that you might have to take either structural walls down or fire lined walls down. Again, what's your plan? What have you done about that? Because potentially, again, we'll go back to dust. You see smoke, existing smoke alarms or existing fire alarm systems, they're bagged to prevent the dust getting in and setting it off and creating false alarms. But if that's left on, again, there's not going to be any detection. Big thing with fire is anyone sleeping in there? If it's a refurbishment project, someone's going to be sleeping in that. It's a hotel, a sheltered accommodation. You need to think long and hard about your controls for maintaining the compartmentation, maintaining the means of alarm, and maintaining the evacuation, because again, it's critically important. Also looking at structural stability, go back to compartmentation, what you're doing about smoke spread, and are you still allowing people to escape? You're not blocking fire exits, because that could be stored materials, it could be mobile towers, could be anything. But again, you're making sure that you're providing an unobstructed means of escape. So a bit of a case study. There was existing windows. It was a refurbishment project that took windows out and replaced OSB doors. We'll talk about an OSB door, because again, you're thinking, what's he talking about, an OSB door? But you'll see a photo in a bit. This is massively relevant as well when it comes to timber frame, and also it had occupied apartments. So within that, on the top floor, there was occupied apartments. However, there was refurbishment work on the ground and first floor. There was a design done. The PCI detailed that there must be a means of escape on the staircase for a minimum of 30 minutes to allow escape from the occupied top floor. That was the door. Now, what's the fire resistance of a sheet of OSB? Well, there isn't one. So down the staircase, there was an OSB, temporary hoardings, the compartmentation was gone. So again, the PCI confirmed that glazed doors on the electrical distribution board must be replaced before any alterations. Item 1 on the programme, however, there was actually glass doors left. So what is the fire resistance of these glazed doors? Again, there isn't one. So there was temporary supplies from an existing board behind the glazed doors, and the arcing occurred because when they were doing the work, they hadn't isolated it. So the temporary board ignites at approximately 1 p.m. The site manager attempted to fight the fire with the only carbon dioxide extinguisher on site. He put it out, in fairness. However, because it was still live, residual heat reignites. So the smoke is now filling the escape stairwell. The fire alarms in the communal areas activate, but smoke control supplies have not been isolated and not reconnected. So again, the battery backup fails to operate the smoke vents. Now got a serious issue. So situation 15 hours later, original structural design precautions maintained? No. Compartmentation maintained? No. Structural stability maintained? No. Fire extinguisher? No. Was the smoke spread being controlled? No. The fire alarm had activated, but it drains after 3 minutes. There's people on the floor prompted to escape, but this means of escape is smoke filled. 1:15, the fire service arrived and they were able to extinguish the fire before it spread to the apartment areas. But the big question is, if this happened at 1:30 a.m. instead of 1:30 p.m., what would the likely outcome be? So, good sources of information for fire control: HSG 168, fire safety and construction. It identifies good processes on how to stop fire occurring in the construction phase. In the left column, within for all construction sites, whereas the right column is for high risk. So if you've got timber frame buildings, again, comes under high risks. And the final section we're looking at existing services. So refurbishment works can be in form of anything. So electric cables, gas pipes, water pipes, other pipelines. So again, flammable liquids, flammable gases, and also telecommunication cables. Now, they might not be carrying a lot of voltage. However, they can cause massive issues in terms of outing certain supplies, etc., which again isn't going to impress the client or any neighbours. So these services, by their very nature, above ceilings, behind walls, above ground level, below ground level. But again, we need a safe system of work. So we need to plan the work, need to detect, identify and mark all services. Can we isolate them if possible? And then safe identification practices. So again, we're looking at hand digging. So we need to look at the extent of the work area, find out what services are present, and consider whether your works are going to likely to disturb these services. So again, can we get service drawings from the utility companies? Survey the site, look for underground services, and making sure you're recording the location of any of these services. Assess the planned works, making sure, can you avoid disturbing them? Because again, can you reroute something? Can you avoid disturbing them? Sometimes you can, sometimes you can't. But you need to make sure there's sufficient time and sufficient resources to carry out the works safely. Sometimes this might be emergency work, but again, we need to assess the risks arising from the work, making sure we're taking a precautionary approach when we're breaking ground or breaking into walls where there could be services present. So we need to locate them, making sure those involved in detecting and identifying them are competent. Have they been trained in the proper use of surveying tools? So if you're giving someone a cat and jenny, have you trained them on them? It's not just a case of, there's a cat and jenny, off you go. You need to make sure they're suitably trained on that as well. And once detected, making sure they're identified and marked, because again, that need to be identified for potential other people as well. So, well, and what they are. Electric cables or the gas pipes, record the location. And again, making sure other people know where they are, because again, the person who's identified them may know where they are, but if there's another worker or another operative in the area, they may not be aware, so they need to be made aware of the services as well. So what we need to look at is the nature and the scope of the work, the type and position, the ground conditions, and any other site with constraints. So again, making sure people are trained and competent, and think about permanent dig as well. So if a service suffers a damage during identification or subsequent work, making sure that the owner of the cable is informed immediately. If it's electric, gas, or other pipelines or high pressure water mains, making sure you're arranging to keep people safe, people in that work area, and making sure that area is closed off and kept safe until it is made safe by the power company, for example. So a bit of a case study. Former hospital building undergoing refurbishment to convert it into residential apartments. The demolition contractor went through a 6-inch gas main in an underground tunnel. No checks had been made about the pipe, its contents, or whether it had been properly isolated. And I don't need to say anything more. I think that picture. So again, that picture paints 1,000 words. It's demolished the whole building basically. If you're identifying them, you need to identify them and then also making sure that there's a point of isolation confirmed before any work commences on site. So just a bit of further information. It's HSE guidance on respiratory protective equipment at work, avoiding danger from underground services, fire safety and construction. So there's plenty out there. If you've got any queries, please let us know. And just potential why you might end up with an HSE visit. So possible investigation following a radar report, concerns from members of the public and workers on site. Remember, every member of the public pretty much has a good smartphone that'll take photos, videos. That can be quite easily sent to the HSE. Licensed asbestos inspections, F10 inspections, but also issues witnessed when inspectors are driving between sites. If there's a big plume of silica dust coming from your site, there's a good chance you could get an inspection. And also targeted campaigns, which we've just spoke about as well. So the aims of these visits are, there's a big focus on the health impacts of construction as well as immediate safety concerns. There's a focus on tasks where respiratory risks are present and making sure that they're taking enforcement where poor standards are found, and to gather information on compliance, so managing of respiratory risks and other health sources on site, including manual handling, noise and vibration. So again, verbal advice, written advice. Remember, fee for intervention, £160 an hour would be implemented. So if there's a notice of contravention, improvement notice, prohibition notice, or potential prosecution, all are going to lead to fee for intervention, which is currently £160 an hour. And the main areas of focus, as we've discussed, asbestos, silica, manual handling, noise and vibration, and other respiratory risks. So